Okay, this is the apparatus for the experiment. You can see a laser pointer, and the light from the laser pointer is passing through a diffraction grating. The interference pattern is projected on that screen at the back of the image. The distance between the screen and the diffraction grating, which is L in your formulas, can be measured by reading the green ruler. And then any distances between maxima that you're going to need to measure, we will be measuring by looking at the meter stick that's resting up against the screen. All right, this is a close-up view of the green ruler. You can see an edge-on view of the diffraction grating in the foreground. The ruler is set up so that 0 on the ruler is exactly at where the screen is. So you're going to have to take a look at this and determine what value you're going to use for L, which is the distance between the screen and the diffraction grating. This is an image showing the bright central maxima when the red laser light is used. You can make out the location of the central maximum, the two n equals 1 maxima, and the two n equals 2 maxima. And what you're going to have to do is use the meter stick to determine the distance from the central maxima to each of the other maxima. You're going to need to collect as much data in this experiment as you can visually see. So when I'm looking at this, I'm seeing that you're going to be able to collect for X 4 different data values. The distance from the central maximum to the n equals 1 on the left, and the distance from the central maximum to the n equals 1 on the right, and then the distance from the central maximum to the n equals 2 on the left, and to the n equals 2 on the right. All right, here's the data image for the green laser light. Again, you can make out the bright central maximum and the two n equals 1 maxima and the two n equals 2 maxima. So again, you're going to have to collect 4 separate data points for this particular laser. All right, now what we're looking at is the image showing the interference pattern when I use the violet laser. You should be able to make out a total of 7 dots here, the central maximum, and then 2 n equals 1 maxima. You'll see a pair of n equals 2 maxima, and you'll see a pair of n equals 3 maxima. That means you're going to be collecting, by looking at the meter stick, a total of 6 data values here. Now for your analysis here in the assignment, you're going to have to do a whole boatload of calculations. You will have a total of 6 calculations for the violet, 4 calculations for the green, and 4 complete sets of calculations for the red. When you determine the wavelength using all of these calculations, it's important for you to note that your final wavelength that you report is found by doing a calculation for the wavelength of red for each of the 4 data points. So you're going to calculate lambda using one set of data. You're going to calculate lambda using a second set of data. You're going to calculate lambda using a third set of data. And for red, you're going to calculate lambda for a 4th set of data. You're going to report as your final result the average of the 4 wavelengths that you get for all of your data from red. You're going to repeat that process and have 4 sets of calculations that need to be done for green, giving you 4 wavelengths that you will average for your final result. And for violet, you are going to have to repeat all of those calculations again, but this time you will do them 6 times, and you will average your 6 wavelengths that you get to record your final result. It's very important for you to note that even though you're doing, by my count, a total of 14 sets of calculations, you're calculating 14 wavelengths, you only need to show a complete set of calculations once in the entire assignment. So if you show all of the calculations and explain them properly, for the first data point for red, you do not need to show me any other calculations for any other wavelength. I hope this helps. We will talk with you later.